Okay, so I'm going to go over the guided notes with you to try and see if I can help you make some sense of some things. What I want you to do is watch it, and then if you still have questions, then we can set up the Zoom to sit and kind of meet. So the first question is, explain what a mole is. Basically, this entire chapter is about using the units of chemistry, which is the mole. Okay, it's the unit that we're going to use to count atoms, molecules, and ions. So a mole is basically a way to count atoms, molecules, etc. Okay, it's a unit of measurement. All right, and the mole is going to be equivalent to what we call Avogadro's number. Okay, Avogadro's number is 6.022 times 10 to the 23rd. Now, here's what this means. A unit called Avogadro's number contains this many items. All right, it's a super big number because atoms are really, really small. All right, so it's going to take a whole bunch of atoms in order to provide enough material to actually weigh. So we can't just, weigh an atom. It's too small. And by the time we accumulate enough atoms to actually have it measure on a scale, that's a lot of atoms that we would need. So we use this number kind of as our starting point. So basically what it means is that 1 mole of any substance, okay, 1 mole of any substance, whether it's carbon, nitrogen, hydrogen, whether it's a compound, carbon dioxide, water. So 1 mole of, and it should be any substance, has what we call Avogadro's number, or 6.022 times 10 to the 23rd.
Braden Mathis to the office, please. Braden Mathis to the office.
Sorry about that. So 1 mole of any substance has 6.022 times 10 to the 23 atoms in it. Everything. Okay, so this is basically kind of like our starting point. So if I want to know how many atoms are in 1 mole of carbon, there's 6.022 times 10 to the 23rd. If I want to know how many atoms of are in water, H2O, there are 6.022 times 10 to the 23rd atoms in a water molecule. If I want to know how many atoms are in a nitrogen, well, there's 6.0223 times 10 to the 23rd atoms. So Avogadro's number gives us basically a benchmark or a starting point in order to understand how many atoms are in a substance. And eventually, we're going to be able to figure out then, we're going to convert later in this chapter, this number into a measurable weight, into grams. Okay, so 1 mole of carbon contains 6.022 times 10 to the 23rd carbon atoms in it. 1 mole of any element, same thing, it contains Avogadro's number, 6.022 times 10 to the 23rd atoms of any element. Same for a compound. 1 mole of carbon dioxide, guess what? It contains 6.022 times 10 to the 23rd molecules of CO2. So, here's how this works. If I have 4 moles of iron, okay, we know that 1 mole of iron has 6.022 times 10 to the 23rd atoms in it. So if I want to know how many total atoms are in 4 moles of iron, here's how this is going to work. We set up a conversion factor. So I'm going to start with 4.00, and this should say mole, sorry, it was a typo on the sheet. 4.00 mole of iron. Okay, set up a conversion factor. We know that mole of iron has to be down here, right? Because we want to cancel those out. We know that 1 mole of iron equals 6.022 times 10 to the 23rd atoms. So now we would multiply 4 times 6.022 to the 23rd. It's going to end up equaling 2.41 times 10 to the 24th atoms of iron in 4 moles. Hopefully you're feeling kind of comfortable with, conversion factors here. So let's just do another quick example problem. How many atoms in 3 moles of carbon? Okay, so we'll take 3 moles of carbon times 1 mole of carbon, and we know that there are 6.022 times 10 to the 23rd atoms in that 1 mole of carbon. Those cancel each other out, and you're going to end up with 1.8 times 10 to the 24th atoms. Atoms is the unit that's left over up here, so you know. So you're just multiplying. Sometimes it's easier, if it's easier just to put that 1 on there, but you can see how that works. So, doing the iron example and the carbon example we just did is pretty simple, all right? You're just going to basically multiply Avogadro's number by the number of moles that you have. It gets a little bit more complicated when we have a compound, okay? So here we have aspirin. It's C8H9O4. So the first thing that you need to know is that in a aspirin compound, there are, look at the subscripts, 8 moles of carbon. Okay, that's what the equation tells you. There are 9 moles of hydrogen, and there are 4 moles of oxygen. All right. So all you got to do is look at the different subscripts down here, and that will tell you how many moles of each individual element is found in the compound. That's it. Look at the numbers, the subscripts. So if I have H2O, and I want to know how many moles of the individual elements there are in this compound, there are 2 moles of hydrogen, there's 1 mole of oxygen. If I have carbon dioxide, and I want to know how many moles of each element is in this compound, there's 1 mole of carbon, there's 2 moles of carbon dioxide. So once we know how many moles there are in this particular compound, now we can take it a step further and answer this question here. Explain how to calculate the number of moles of carbon present in 1.5 moles of aspirin. So here's what you're going to do. Take what you start with. We have 1.5 moles of C8H9O4. Okay? If you want, you can put that over 1. We know that moles of aspirin has to be down here, right? Because we want these to cancel out. And the problem tells us that we have 1.5 moles of aspirin. So that's here. we know that in 1 mole of aspirin, there are 8 moles of oxygen, or of carbon, okay, C8. So we would put up here that there are 8 moles of carbon in 1 mole of C8H9O4. So hopefully you see where I was getting that. We got in this particular 1 mole of this compound, there are 8 moles of carbon that make up it. We got that from looking at the subscript down here. So now you just, again, multiply across. Okay, 1.5 times 8 equals 12. So we know that in this entire, in 1.5 moles of this compound, there are actually 12 moles of just carbon. So let's try another one. Let's try H2O. Okay, how many moles of hydrogen are there in 2.0 moles of water? Right? So start out with what you have. You have 2.0 moles of water. Okay? Moles of water will be down here. We know that in 1 mole of water, there are 2 moles of hydrogen. We got that from the subscript. Okay? So multiply across. You end up with 4. So in 2 moles of water, there are actually 4 moles of hydrogen. Think about it kind of like a recipe, okay? How many ounces in a gallon? How many milliliters in a liter? You're really just converting. All right, so for number 9, define molar mass. Well, that's the quantity of grams that we use that equals the atomic mass of an element. So what this basically means is that 1 mole of a element, or a compound for that matter, is going to equal the atomic mass in grams. Okay, so 1 mole of carbon is going to equal 12 grams of carbon. All right, 12.01. Usually we go to the 100th place. So you're going to look at the atomic mass of each number. Okay, nitrogen is 14.00. Phosphorus is 30.97. So 1 mole of phosphorus has 30.97 grams. Okay, 1 mole of aluminum has 26.98 grams. 1 mole of boron has 10.81 grams. So we can use this information now in order to, again, do conversions. So if we have this many Avogadro's number of atoms of carbon, that equals 1 mole of carbon, right? We talked about that earlier. 1 mole of carbon has 6.022 times 10 to the 23rd atoms in it. And 1 mole of carbon has 12.01 grams of carbon dioxide, okay? This is the atomic mass. So if you look at silver, okay, 6.022, 23 atoms of silver is 1 mole of silver. Look at your periodic table then. 1 mole of silver. Let's see, where's silver on here? Right here. 1 mole of silver has 107.87 grams of silver atoms. Okay? So remember earlier when we talked about how there's so many atoms, we have to figure out how to weigh these small atoms. This is how we do that. So in 107.87 grams of silver is 1 mole of silver, and that contains 6.022 times 10 to the 23rd atoms of silver. All right, so here's how we kind of put all of this together to figure out the molar mass of a compound. All right, so calculate the molar mass of salicylic acid C7H6O3, which is used to make aspirin. All right, so the first thing you need to do is we need to figure out how many moles of each element we have. Well, we know there's 7 moles of hydrogen, there's 6 moles of hydrogen, or 7 moles of carbon, there's 6 moles of hydrogen, and there's 3 moles of oxygen. All right. The next thing that you're going to do then is find their atomic mass, right? So carbon is 12.01. Hydrogen is 1.01. Oxygen, 15.99, so we would round that up to 16. Okay? And this is going to tell you how many grams there are of each of these in this element. So 7 times, do the math here, 12.0. And then you're going to take these and you're going to add them all together. So 48 plus 6.06 plus 84 gives you 138.06 grams of C7H8O3 in 1 mole. So just to recap, to figure out the number of moles in a compound, look at the subscript, 7H6, 6 moles of hydrogen, O3, 3 moles of oxygen. Then take the number of moles times the atomic mass that you find on your periodic table. And then in order to find the molar mass for the entire thing, you would add them all up.